Good morning, everyone. I'm Xingsu, the PhD candidate from Macquarie University in Sydney. It's my great pleasure to present this work. The title of this work is Mining User-Aware Multi-Relations for Fake News Detection in Large-Scale Online Social Networks. And I would like to present this work in the following 5 aspects. Firstly, let's get started from the motivation. You know, nowadays, more and more people prefer to get information from the online social medias like the Twitters or Facebook. It's very convenient for us to get the information, but it also brings a negative side, the brazen spread of the fake news. Here is a piece of fake news about COVID-19. It already caused more than 5,800 hospitalizations. So obviously, it's very necessary for us to design the algorithms for fake news detection in the online social networks, to provide the trustworthy information to the public. And until now, there are already many researchers focused on this problem. And the text-based methods, they only consider the textual content of the news itself. But it has a drawback, if we made some news in the specific domain, if we don't have the knowledge in that domain, it's hard for us to distinguish the news, whether it's real or fake. So with the development of graph learning, the graph-based method tries to construct the graphs of the word or sentences like the situation 2. And some method also try to construct the news propagation graph like the situation 3. And also there are some methods try to construct the social content for detect the fake news. But this method still facing some challenges. First of all, if we consider the user information in the online social networks, user interaction is very dense, and maybe this method will make to the problem of neighborhood explosion. So most of method ignore the influence of user interaction and the fake news spreading. And apart from that, because some important structural information is ignored, so maybe we can just get the limited performance. And the third challenge is about the efficient detection in the large-scale networks. This kind of technology still require the further development. So our methods are proposed to address these challenges. Specifically, we designed a method named AskDeepFake to capture the user-aware multi-relations for detecting fake news. As we can see in Figure 1, in order to address the challenges, we firstly crawl the data from Twitter, and then we construct the information of news and users into this attributed dual-layer graph. We can see here we have the 2 intra-layer graph and 1 interlayer. The first interlayer is the news graph, and the second interlayer is the user graph. And the interlayer between these graphs are represent the posting relation between the users and the news. Based on our constructed graph, we also conclude that our contribution into these 3 aspects to address the first challenge about that some method ignored the information of users. We mask the multiple relations, including the user interaction information, to learn in the online social networks, and that can learn the distinguishable user-aware embeddings of news. To address the second challenge about the limited performance, our experiment shows that the AskDeepFake can surpasses the SOTA baselines. And the third challenge about the efficient detection, to address this problem, our method designs a graph sampler to detect the fake news efficiently in the large-scale networks. So let's move on to the methodology. Here is the framework of SDFake. We can see this model has the 4 modules. After we import the dual layer graph in the graph sampling module, we can get some small scale subgraphs to speed up the following training. And each subgraph is a dual layer graph, so we can fit the news graph into the news propagation module and the user graph into the user interaction module. And we train these modules together, and while we're training them, we fit the user embedding into the news embedding through the interlayer, so we can keep fighting the news embeddings through this user information. Finally, we can get the user-aware news embeddings. This embedding can contain the user interaction information. And finally, we feed this embedding into the detection module to get the final result of the real and fake news. And specifically in the graph sampling module, we use the random walk to get some subgraphs. And for the news propagation module, we use a sampling-based GCN named graph site to learn the news embeddings. And for the user interaction module, users have no labels in this work. So we use the autoencoder to learn the user embeddings in the unsupervised learning. And after we get the updated user-aware news embeddings, we feed it in the softmax or to classify the news into real and fake. That's it for the method. Let's move on to the experiment. To test the performance of our method, we use the 2 real-world data sets from the fake news data, and the data sets named the PolitiFact and Gossip Cop. Here in table 1 is the data statistics of the our constructed dual layer graph. Our first question about is does SDFake can outperform all the baseline method in our experiments? Here, SDFake/C and SDFake/A means that our method use GCN or GAT in the convolutional layer. We can see in this table 2, both of our method can get the optimal or suboptimal results. And the second question is, does SDFake benefit from the multiple relations? To answer this question, we set the ablation study. Here, defake means that we only learn the news embedding. And the U-defake means that we learn user embeddings and the news embeddings separately and later combine them together. And SDFake is the method I just introduced. We keep fighting the news embedding through the user information. And we can see that user credibility information is quite important and useful for fake news detection. And keep fighting the news embedding through the user information also works so good. And to test whether the model is sensitive to the parameters, and we set this analysis, and the results say that our model can get the stable result in the most of parameter settings. The last question is about efficiency. Here we recorded the average training time of each epoch. It shows that our method can perform efficiently on the data sets with more than 500,000 nodes and more than 1 million ages. But there is still a drawback of this method. The density of the subgraph obtained by sampling can cause the fluctuation in runtime. So in conclusion, we find that interaction relation between users can reflect a user credibility, and this kind of credibility has a positive correlation with news authenticity. And through the experiments, we also show the superiority and efficiency of our proposed model. And so in the future, we plan to address the training time instability caused by the graph sampler, and we will also plan to explore early detection of fake news in propagation. Thank you for your attention, and our code is available through this link. Thank you.